Welcome, all the students who are preparing for this upcoming NEET exam 2025. And today we are going to discuss some of the questions that is from the physics section. So, uh, the first question is a particle is executing uniform circular motion with velocity v and acceleration a. Which of the following is true? So, four options are there. So, we know that in a uniform circular motion, so this word is uniform and circular motion. In a circular motion, and it is also said that the circular motion is uniform. It means that something is uniform there. So what is uniform? That is the speed. In uniform circular motion, the speed is uniform. That means the magnitude of the speed is constant. And what about the velocity? The velocity is, what about the velocity? The velocity is always changing. At each and every instant, along a uniform circular motion, the velocity is changing. And the direction of velocity is given by the tangent drawn at each and every point along the circle. So only the direction gets changes and each and every point the speed is a constant. Thus we can say that in uniform circular motion, even though the speed is constant, the velocity is not at all constant, it is changing. And what about acceleration? At each and every instant, the acceleration is towards the center of the circle. So even though the magnitude of acceleration is also constant throughout the uniform circular motion, but this direction get changes. Therefore, we can say that velocity is not a constant as well as acceleration is not a constant. So option B is the right answer. Now we shall move to the next one. So I hope you can see this question. Here, the question is, a ball is projected from point A with velocity 20 meter per second at an angle 60 degree to the horizontal direction at the highest point B of the path, and the velocity of the ball will be. So we are supposed to find the velocity of the ball at the highest point. So in a projectile motion, we know that it's a two-dimensional motion. And this velocity, the initial velocity can be it has two components. One is a horizontal component and the other is a vertical component. So at the highest point, the vertical component of the velocity will be zero. Only the horizontal components, it remains constant throughout the projectile motion. Therefore, at the highest point, we have only this horizontal component of velocity, and this horizontal component of velocity, which is given by v is equal to v cos theta. V is the initial velocity, cos theta is the angle which the velocity, the initial velocity makes with the horizontal. So we can write at the highest point, velocity will be v cos 60 degree. Cos 60 degree, we know that it is half, and we can write it as v by 2. So the magnitude of initial velocity is given, and it is given as 20 meter per second. Therefore, at the highest point, we get the velocity as the highest point, the velocity will be 20 by 2. That is 20 by 2, that is 10 meter per second. So I hope it's clear for you. That's all about this question. Let's move to the next one. The next question is from the chapter Electromagnetic Induction. So the question is like this. A loop of wire is placed in a magnetic field B, that is B, the magnitude of magnetic field is given in the question, that is 0.6 J Tesla. Find the flux through the loop if the area vector A is equal to 3I plus 2J minus 6K. So what is given? Both the magnitude of magnetic field as well as the area vector is given. Both these quantities are given in the vector form. Therefore, we can write B, the vector B is equal to 0.6J. Since only one component is given, we can write it more clearly as 0I plus 0.6J plus 0K, this much Tesla. So what about the area vector? The area vector can be written as A is equal to 3I plus 2J minus 6K meter square. So we are supposed to find the flex here. We know that flex phi is equal to area vector dot product area vector dot magnetic field vector. So B dot A. So we can write this as 0I plus 0.6J plus 0K dot 3I plus 2J minus 6K. We know that I dot I is 0. Sorry, I dot I is 1 and J dot J is 1 and k dot k is 1. Since the magnitude of I and k are 0, we can write 0.6j dot 2j. That will be 1.2. 1.2 will be the answer. We know that the unit of flux is Weber. So this much Weber is the answer. I hope this question is also clear to you. So let's move to the next one. So this is the next question. Here we are given the position of a particle is given as it is r of t is equal to 4ti plus 2t square j plus 5k, where t is in seconds and r is in meter. And we need to find the magnitude as well as the direction of velocity at t is equal to 1 second with respect to the x-axis. And we need to find the direction with respect to the x-axis. For this, we can do it like this. R of t is given. R of t is equal to 4t. In terms of t, the position vector R of t is given. That is 4ti plus 2t square j plus 5k. And from this, how can you find the velocity vector? We can find the velocity by just differentiating the position vector with respect to what? Time. And differentiating this 4ti plus 2t square j plus 5k, we get 4 plus 4i plus 4tj. So this is the velocity vector, and the velocity at the time 1 second we need to find. Therefore, velocity at time t is equal to 1 second. It is like 4i plus 4 into 1j. That will be 4i plus 4j. So this is the magnitude in vector form only. This is in a vector form. So on finding the magnitude, we get velocity is equal to, by using Pythagoras theorem, we can draw it like this. This is 4i and this is 4j, and the resultant vector will be in this direction. And this direction we need to find. That is the direction of the velocity vector with respect to the x-axis. Therefore, this direction is, since we know that this is a right angular triangle and this is having same magnitude for both the perpendicular as well as the base. Therefore, this is by using Pythagoras theorem, we get 4 root 2 meter per second as the answer. That is the magnitude of velocity. And what about the direction of velocity? The direction of velocity is this theta. We know that this both magnitudes are same. Therefore, this theta and this theta will be same. Therefore, we know that the sum of the angles of a triangle is 180. Therefore, one of the side is 90. That means the other two sides will be 45 degrees. So the direction of theta will be what? 45 degrees. So from this question, we find out the magnitude of velocity in vector form as well as the magnitude form only and the theta. I hope this question is also clear to you. So let us go to the next question. Next question is about the average speed. A vehicle travels half of the distance with speed v and the remaining half with speed 2v. Then the average speed is. So we know that, suppose in this question, we can divide this question into two parts. Like in the first let the distance be x. And then the second also the same distance, so it be x only. So what about the speed in the first case? That is v. For the first half distance, the vehicle travels with the speed v, and the next half distance it travels with the speed 2v. So what is the average speed here? What is the average speed here? So what is the equation of average speed? The equation of average speed is the total distance by total time. Total distance by total time. So we are not given time here. So what should we do here? So we know that speed is equal to distance by time. Therefore, distance can be written, time can be written as distance by speed. So V average will be, or S speed average will be, total distance is x plus x. And the total time will be, the first time we can write T1 is equal to distance by speed, that is x by V. And T2 will be what? X by 2V. So The total distance by total time will be t1 plus t2, that is x plus x 2x by t1 is x by v, and what about t2? It is x by 2v. And solving this, we get 2 by 2 by v plus 1 by 2v, 2v, 2 by 2v plus 1 by 2v, that is 2 by 3 by 2v, and 2 into 2v by 3, that is 4v by 3. The option C is the correct answer. So thank you.